My name is Samantha Davis, and this is my final Psych 216 assignment where I thoroughly explain how to solve the following problems. Please follow along with the Word document that corresponds with this explanation. The problem we are given states, a researcher is interested in whether there is a relation between what elementary school children learn from stories they read and what they learn from stories viewed on television. The researcher is able to obtain two children's stories in each of the two forms, an illustrated book and a television production. The researcher does the following experiment. Each of 48 children, half second graders and half fifth graders, are presented with two stories. The children read one story and see the other on TV. The researcher counterbalances order of presenting stories and assignment of a story to a medium, and those assignments are equivalent for children in the two age groups. Following the presentation of each story, each child completes a test of what the child can remember from the story. Each child is given a comprehension score for each story. The main question we have is to suppose that the researcher studied the relation between TV and reading comprehension separately for the two groups. We are given a set of data, and we are mainly concerned with the correlation scores and the sample sizes. So for second graders, R is equal to 0.19 and the sample size is equal to 24. And for the fifth graders, R is equal to 0.31 and the sample size is equal to 24. We are first asked to perform a hypothesis test on the relation between TV and reading comprehension for two age groups. We first want to start off our hypothesis testing by stating the null and alternative hypotheses. Row 1 is going to equal the second grader's data, and row 2 will equal the fifth grader's data. So therefore, the null hypothesis is row 1 minus row 2 equals 0, which indicates there is no difference between the relation of the two scores, and therefore the alternative hypothesis is row 1 minus row 2 does not equal 0, which indicates there is a difference between the relation of these two scores. After we have set up our null and alternative hypotheses, we can look at what test statistic we need to use and the alpha level we need to use. You would use the z-test based on z-prime transformation of two sample r values because the question concerns differences between two population correlations. The test you would perform is given in the formula below, which reads, obtained value of z is equal to z prime 1 minus z prime 2 divided by the standard error of z prime 1 minus z prime 2. For this hypothesis test, our level of significance is going to be alpha is equal to 0.05. Even though it was not given in the problem, it is most common to assume an alpha of 0.05. With all of that information, we can now set up our rejection region. Once again, normal distribution is the sampling distribution, so use the normal distribution table to find the rejection region. Since alpha is equal to 0.05, and this is a two-tailed test, you know you need to divide alpha at each end of the bell curve. So you would divide alpha by 2, and this would result in 0.025 in each tail of the bell curve. Since this is in terms of the area falling between 0 and the z-score, this means it would have to be 0.475. When we look for 0.475 on our normal distribution table, we find z to be equal to 1.96. This leads to the critical z-value equaling plus or minus 1.96. It is plus or minus due to the fact that this is a two-tailed test. Therefore, the rejection region is reject the null hypothesis if the obtained z-value is less than or equal to negative 1.96, or if the obtained z-value is greater than or equal to 1.96. The next step is to use our results to perform the actual statistical test. Remember, we are using the equation obtained value of z is equal to z prime 1 minus z prime 2 divided by the standard error of z prime 1 minus z prime 2. To begin the statistical test, we need to transform the r values to z prime values using the table of z prime values. So, R1 is equal to 0.19, which corresponds to a z prime score of 0.192, and R2 is equal to 0.31, which corresponds to a z prime score of 0.321. Now it's just a matter of plugging all the data we have into our formula. So then we calculate our z obtained. 0.192 minus 0.321 divided by the square root of 1 divided by 24 minus 3 plus 24 minus 3. So then our numerator should equal negative 0.129 and the denominator should equal 0.15430,335. The z obtained value should then equal negative 0.836, which we can round up to negative 0.84. We are now able to make our decision and our conclusion. Since negative 0.84 is not less than or equal to negative 1.96 and is not greater than or equal to 1.96, our z obtained does not fall into our rejection region and we cannot reject our null hypothesis. You can then conclude that there is insufficient evidence of a relation between what elementary school children learn from stories they read and what they learn from stories viewed on television with these two age groups. Next, we are told that the researcher then decides that he really wanted to know about the relation between TV and reading comprehension across elementary school. So he decides to combine both grade levels into one sample of 48 and then test the relation for the entire sample. For the sample of 48 second and fifth graders, the researcher obtains a sample correlation between TV and reading comprehension of R equals 0.62. So basically, our new test combines both grade levels into one sample, and the important data in that sample is that the sample size is 48 and the calculated correlation is 0.62. Since the test for this question has been changed, we now know that the new hypothesis test would change to single population correlation because we are concerned with a single population where rho is equal to 0 and we don't need to calculate our correlation value. Our new null hypothesis for this set of data is rho is equal to 0, and our new alternative hypothesis would be rho does not equal 0. Using our new data, we are asked what the rejection region for this specific test would be. Since the hypothesis test changed to a single population correlation, we now need to solve for our rejection region differently than we did earlier. In this situation, we know that alpha is 0.05, again this is assumed, and that it is a two-tailed test. We need to solve for degrees of freedom. Degrees of freedom is equal to n minus 2, so in this case, the degrees of freedom is equal to 48, the sample size, minus 2, which is equal to 46. To find our R critical value, use the critical values of Pearson's R table. You then find that R critical approximately equals 0.2875. This is only approximate due to the fact that degrees of freedom jump from 45 to 50 and the closest value to 46 on this table is 45. Therefore, we use the value from 45 to approximate our answer. The rejection region would be to reject the null hypothesis if the obtained R value is greater than or equal to 0.2875. Now that we have all this information, we can make our decision and conclusion. Since we are given R is equal to 0.62 and 0.62 is greater than 0.2875, we would reject the null hypothesis. We can then conclude that there is sufficient evidence that indicates that there is a relation between TV and reading comprehension across elementary school. The final thing we were asked to do with these problems was to think very carefully about the difference between the original test and the second test, and to discuss reasons for differences in the conclusions that were reached for each test. In particular, you should address reasons why the magnitude of the correlation in the second differed from the magnitude of the correlations in the first test. Well, one main reason that these outcomes differed was because they were testing two different things. The first test we performed was testing the relation between TV and reading comprehension separately for two age groups, whereas the second test was testing the relation between TV and reading comprehension across elementary school aged children. It is possible that one of these can have a relation and one cannot, as we found in our results. The magnitude of the correlation differed from the two tests mainly because in the first test we were testing two separate populations with smaller correlations, and in the second test we were testing both populations combined with a combined and larger correlation. Well, that's all I have. Thank you for watching my video, and I hope you were able to follow along with my explanation in the slides that I made.